Hi, my name's Audra. This presentation is titled Modernizing Enterprise Data Management Advisor, an ETL-centric approach to scalable and governed data architecture. This presentation examines how extract, transform, and load, or ETL, serves as the strategic foundation for enterprise data management modernization within a global pharmaceutical organization. In a data-intensive organization such as Pfizer, information flows continuously from diverse sources, including clinical trials, regulatory systems, manufacturing pipelines, and global supply chains. Over time, these systems have developed independently, often resulting in fragmented data silos that limit enterprise-wide analytics. As Pfizer advances its digital transformation initiatives, the need for a unified enterprise data management platform becomes increasingly critical. At the center of this transformation lies the modern data integration approach of ETL. While often framed as a technical process, ETL is more accurately understood as a strategic mechanism that enables data consistency, reliability, and usability. From business intelligence perspective, Pfizer is a data-intensive, research and development-driven organization whose performance depends on effectively integrating clinical, commercial, and market data to guide decision-making across global operations. With revenues exceeding $60 billion a year and a business model centered on patented drugs and vaccines, Pfizer relies heavily on analytics for demand forecasting, product lifecycle management, and portfolio optimization. Business intelligence systems are therefore critical in transforming large-scale scientific and financial data into actionable insights that support competitive positioning, cost efficiency, and long-term innovation strategies. Understanding ETL. ETL refers to the process of extracting data from disparate systems, transforming it into standardized and usable format, and loading it into a centralized repository such as data warehouse. In Pfizer operational context, ETL plays a critical role in integrating clinical, operational, and financial information. For example, clinical trial data may originate from multiple platforms, including electronic data capture systems and laboratory databases. During extraction, this data is collected in its raw form. The transformation phase standardizes measurement units, resolves inconsistencies in patient identifiers, and applies business logic. Finally, the load process, or load phase, stores the process data in a structured warehouse for analysis. This process ensures that downstream analytics rely on consistent and trustworthy data, which is particularly important in regulating environments where accuracy and traceability are essential. The importance of ETL has grown significantly due to several converging trends. First, the volume and capacity of data have increased dramatically, including both structured and unstructured data, such as genomic databases and real-world evidence. Second, regulatory requirements demand transparency and auditability in data processing, requiring ETL pipelines to incorporate data lineage tracking and validation mechanisms. Third, the rise in advanced analytics and machine learning has increased the demand for high-quality data. Poor quality data can significantly undermine predictive models. Finally, cloud computing has transformed how data is stored and processed, enabling scalable ETL structures that support both batch and real-time processing. ETL is often discussed alongside data mining and decision support systems. However, these concepts serve distinct roles within the data ecosystem. ETL focuses on data integration and preparation, ensuring that data is clean, standardized, and accessible. Data mining involves the discovery of patterns and relationships within prepared data sets. Decision support systems provide tools for interpreting data and making informed decisions. Thus, ETL serves as a foundational layer upon which both data mining and decision support systems depend. ETL process. Within business intelligence and data warehousing environments, ETL plays a central role in ensuring data consistency and usability. Unlike transactional systems, which prioritize operational efficiency, data warehouses are designed for analytical queries and historical analysis. ETL enables this by consolidating data from multiple sources, maintaining historical records, and structuring data into dimensional models. This allows organizations such as Pfizer to perform longitudinal analyses, including tracking patient outcomes over time and identifying trends in manufacturing performance. A structured ETL modeling process is essential for successful data migration and integration. The proposed approach includes identification of source systems, data extraction using batch and streaming methods, data profiling and validation, transformation including cleansing and enrichment, loading into staging areas and data warehouses, and continuous monitoring and auditing. This layered architecture ensures scalability, data quality, and regulatory compliance while supporting both historical reporting and near real time analytics. A dimensional model based on the STAR schema is recommended for Pfizer's data warehouse. In this design, a central fact table captures measurable events such as clinical trial outcomes, while surrounding dimensional tables provide contextual information, including patient demographics, drug information, time, and location. This structure simplifies queries and improves performance. In addition, cloud-based platforms such as Snowflake, which would be my recommendation for Pfizer, and Amazon Web Services Redshift provide scalable infrastructure, while big data technologies such as Apache Spark and Hadoop support large-scale data processing. The modernization of enterprise data management at Pfizer represents a strategic transformation rather than a purely technical upgrade. At the core of this transformation is ETL, which serves as a critical bridge between fragmented legacy systems and, and a unified analytics-ready data ecosystem. By implementing structured ETL processes, organizations can ensure that data is integrated, cleansed, standardized, and governed to support high quality decision making. The integration of data governance, metadata management, and master data management ensures compliance, consistency, and security across the enterprise. Furthermore, the incorporation of big data technologies and data visualization enables advanced analytics, including machine learning and real time decision support. Ultimately, this ETL-centric architecture transforms data into a strategic enterprise asset, enabling innovation, providing operational efficiency, and sustaining competitive advantages in a highly data-driven industry. Thank you.